one. Here we go.
Good morning or afternoon or whenever you're watching this. We, JENATA, Areeba, and Patrick are from Group 8, and we're going to talk about our project where we made a remote controlled car using microbits. Next, please. Next slide. So we're going to talk a bit of how the car works and all the features that we made. And we're also going to talk about the learning process or the steps that we took to achieve. Next slide, please.
Okay, so the system is made of two main parts, and first is the remote controlled car, and second is the handheld controller. Together, the system allows the user to move and control the car using the remote controller, and the user can also use several other features that will be explained later. Next slide, please. So this is the system architecture of the remote controlled car. As you can see from the diagram, the car uses several main components. It is powered using a 7.4-volt battery, which is then regulated using a low dropout voltage regulator into 5-volt for the ultrasonic sensor and 3.3-volt for the microbit. On the top left, you can see that the left and right motors are connected to the microbits using several pins. For example, this PWM, or pulse width modulation, is for controlling the motor speed, and below that is for controlling the direction. On the bottom right, you can see that there is an ultrasonic sensor connected in the system. The sensor is connected using two pins, which is the trigger and the echo. Using the sensor, the car can detect any obstacles. Next slide, please. As for the handheld controller, we only use the microbit without connecting it to other components. However, we utilize many features provided by the microbit, such as the touch logo, the LED, buttons, speakers, accelerometer, and processor. On the back side of the microbit, you can see that there is the radio antenna. Using this, the controller and the car can communicate with each other. This is how we are able to send commands to the car using the controller. Next.
So the very first step that we took is to understand the hardware, like where to put the pins and understand what each pin does. And then we gone to plan our features that we're going to use. And then we study the codes based on the microbit documentation for each features that we wanted to use. And we also try to not use Tinkercad or Acode just to be familiar with the functions and classes or syntax used in the Mu Python editor. So once we studied the code, we go on to explore each module, like testing one by one if the features and the codes work. And lastly, we compile all the codes and see if the car and the remote successfully executes all of them smoothly.
Okay, so now we're going to be talking about the basic features that this card, the card that we've made demonstrates. So as mentioned before, there are two microbits, one attached to the car and one used as a handheld remote. And the car obviously has motors that allow the car to move. So when we press various buttons on the handheld microbit, we're able to move the car in several directions. For example, if we touch the logo, then the car will move forward. If we touch pin 2, it will move backward. If we touch buttons A and B, then the remote controlled car moves left and right respectively. We can also control the acceleration via this handheld microbit. As we tilt the microbit, the remote controlled car also moves in the direction that the remote was tilted. It accelerates in the direction that the remote was tilted in. The car also has attached ultrasonic sensors. Now, the job of these ultrasonic sensors is to sense any obstacles in a 15-centimeter radius and thus prevent any harm from coming to the car. So how this works is basically the ultrasonic sensors detect any obstacles within the 15-centimeter radius, and then the microbit attached to the car sends an alarm signal to the handheld microbit, which is used as a remote, via radio communications. And then an alarm is sounded. This alarm is sounded, and the user who is operating the microbit using this operating the car using this handheld remote can stop the motors. Now, along with these basic features, the device that we've made, the car that we've made, also has a few extra features. One of them is to display the ambient temperature. The microbits can sense the temperature in their surroundings, and that's exactly what we have made with that. That's exactly what the microbit on our car does. It senses the temperature in its surroundings and then displays that via the LEDs on the microbit. The microbit is also programmed to show the direction in which the car is moving. So in whichever direction the car is moving, the LEDs on the microbit on the car will show arrows pointing in that direction. Now, the car can also produce horns or sounds as we press buttons on the remote. So for example, if we press buttons A and B on our remote, then the car sounds a horn. In the case of obstacles, which the ultrasonic sensors detect, as we mentioned before, if there are obstacles, then the microbit can also display the distance between the car and the obstacle using the LEDs. So these are the extra features that the car displays. So the car that we have assembled and made, the remote control car that we have assembled, can successfully demonstrate all the features that we've mentioned in the previous slides. Thank you very much for watching.